Question number 3a. Phi of s is given as s plus 3 the whole square, that gets divided by s square plus 6s minus phi the whole square. And we need to do this using convolution theorem. I need to find inverse of this using convolution theorem. So let's start with solution. I just define here, we need to find inverse by convolution theorem. Phi of s is s plus 3 the whole square, whole gets divided by s plus 3 the whole square minus phi and further minus 9 the whole square, which I can write as s plus 3 the whole square, that gets divided by s plus 3 the whole square, and this comes to be minus 14 the whole square. So we can write L inverse of phi of s is e raised to minus 3t L inverse of s square divided by s square minus 14 the whole square. So we just need to find inverse of this and we can substitute it here. So guys, I start with phi 1 of s is s divided by s square minus 14, and phi 2 of s is again s divided by s minus 14. So I can say f1 of t comes to be cos hyperbolic root 14t and f2 of t comes to be cos hyperbolic root 14t. So now we can put it into a formula. Before that, let's define here itself. f1 of u is cos hyperbolic root 14u and f2 of t minus u is cos hyperbolic root 14t minus u. So now L inverse of phi 1 of s into phi 2 of s, that is equal to 0 to t f1 of u into f2 of t minus u du. Let's substitute. So that comes 0 to t. f1 of u is cos hyperbolic root 14u, further is cos hyperbolic root 14 t minus u du. So cos and cos comes to be 1 by 2 cos hyperbolic a plus b, so root 14u plus root 14t minus root 14u, further plus cos hyperbolic a minus b, so I can say root 14u minus root 14t plus root 14u du. So we can write this as 1 by 2 0 to t cos hyperbolic, this and this gets cancelled. We can write directly cos hyperbolic root 14t plus cos hyperbolic root 14. Taking root 14 common, you can write as 2u minus root 14t into du. So let's integrate this. That comes to be 1 by 2 cos hyperbolic root 14t comes to be constant, and integration of u is u. Integration of du with respect to du is u, upper limit is t, lower limit is 0, plus sin hyperbolic root 14 2u minus root 14t, this gets divided by root 14 into 2. So let's substitute. I get finally as 1 by 2 t into cos hyperbolic root 14 t, next is plus 1 upon root 14 into 2. When we substitute here t, that comes to be sin hyperbolic root 14. When we take root 14 common, there is no root 14 here, students, extremely sorry for that. So we have only 2u minus t. When we substitute t, 2t minus t is t sin hyperbolic root 14t, and next is when we substitute 0, that comes to be sin hyperbolic root 14 minus t, minus of sin hyperbolic root 14 of minus t. So we can write this as 1 by 2 t into cos hyperbolic root 14t plus 1 upon 2 root 14. This comes to be further sin hyperbolic of minus theta, so that comes minus, so this becomes plus, which we can write as 2 times of 2 sin hyperbolic root 14t. So this and this gets cancelled, and finally I get 1 upon 2 t into cos hyperbolic root 14t plus 1 upon root 14 sin hyperbolic root 14t. Now we can keep this answer after multiplying e raised to minus 3t. So I can say finally L inverse of phi of s, that is equal to, we have e raised to minus 3t multiply, which is divided by 2, and further t cos hyperbolic root 14t plus 1 upon root 14 sin hyperbolic root 14t. That completes my answer.